So, you got this equation that you need to solve, but it's got fractions in it. Don't panic. We can handle this. You can use the multiplication property of equality to kill the fractions. Remember, you're allowed to multiply both sides of an equation by the same number. If you do that with a cleverly chosen number, you can turn your equation into one without fractions. The cleverly chosen thing that you should multiply by is, well, if there's just one fraction, you can multiply by the denominator of that fraction. Here's an example of that. 2/7 x equals 4. Notice the denominator, 7. I'm allowed to multiply both sides of this equation by 7. So 7 times 2/7 times x equals 7 times 4. But then 7 times 2/7 would just be 2. The 7/7 is just 1. And then 1 times anything else is just that anything else. So we've eliminated the fractions, and we're down to 2x equals 28. From here on out, we just divide both sides by 2, and we get x equals 14. Now, there's other ways we could have done this. We could have said, okay, we have a number times x, divide both sides by that number. So you just have to divide both sides by the number 2/7, which is fine if you know how to divide by a fraction. You multiply by the reciprocal. Or you could have just said, let's multiply both sides by the reciprocal of 2/7, which would be 7/2. That works. But this trick of just multiplying by the denominator is going to come in handy when we have more than one fraction. So if there's more than one fraction in your equation, what you can do is look at all the denominators of any fractions in the equation, figure out what the lowest common denominator of all those fractions would be, or it doesn't necessarily have to be the lowest common denominator as long as it's a common denominator, but lower is better. Find a common denominator of all the fractions, something that's a multiple of all of them, and then that's what you want to multiply by on both sides of the equation, because that will allow you to cancel all the denominators. So in this example here, 1/2 times or plus x/5 equals 9/10. We've got denominators 2, 5, 10. We need something that's a multiple of all of those. It has to be divisible by 2, and divisible by 5, and divisible by 10. Well, 10 would work. 10 is divisible by all of those numbers. So let's multiply both sides by 10. 10 times 1/2 plus x/5 equals 10 times 9/10. So now, notice the distributive property says that this is 10 times 1/2 plus 10 times x/5. So each term is getting multiplied by 10. And the reason that's a good thing is because this 10 times this 1/2, 10 times 1/2, would just be 5. And this 10 times this x/5, well, 10/5 is 2. And then that 2 times this x is 2x. Meanwhile, on the other side, this 10 times 9/10 is just 9. The 10/10, well, 10 divided by 10 is just 1, and then 1 times 9 is 9. So, look, we've killed the fractions. No more fractions. Just a nice, simple, innocent little equation, 5 plus 2x equals 9. We can handle that. So from here, just subtract 5 from both sides, 2x equals 4, and then divide both sides by 2, x equals 2, and there's our solution. If you want to check, 1/2 plus 2/5, 1/2 plus 2/5 does equal 9/10 if you add them according to the rules of fractions. Or if you do them in decimal form, 1/2 would be 0.5, 2/5 would be 0.4, add those together you get 0.9, which is what 9/10 would be in decimal form. Okay, another example, x/3 minus x minus 5 over 5 equals 3. What can we multiply by that will kill off both of these denominators? We need something that's divisible by 3 and divisible by 5. How about 15? So I'm multiplying both sides by 15. 15 times x over 3. Well, 15 over 3 is 5, and then times the x. Minus, now here the 15 over the 5 would be 3, and so that 3 gets multiplied by the x minus 5. And then over on the other side, nothing divides out, it's just 15 times the 3 that was there. Okay, so now there's no more fractions. Now we just continue on with our strategy. Multiply this out to remove the parentheses. We get 5x minus 3x plus 15, because a minus 3 times a minus 5 is a plus 15, equals 15 times 3 gives me 45. See any like terms we can combine? 5x minus 3x is 2x. So now 2x plus 15 equals 45. So now, to leave the x term by itself, we want to get rid of the plus 15 by subtracting 15 on both sides. So then 2x equals 30. And now divide both sides by 2, and we get x equals 15. Ta-da! There's our solution. And if you check that, 15 over 3 would be 5. 15 minus 5 would be 10, and 10 over 5 would be 2. And then 5 minus 2 does equal 3. Now what about this example? I see some fractional expressions here with denominators of x minus 6. So since that's the only thing in any denominator, we can kill those denominators by multiplying both sides of this equation by x minus 6. So let's do that. Let's multiply both sides by x minus 6. So then x minus 6 times x over x minus 6 would just be x. The x minus 6 over x minus 6 cancels out, just gives you 1, and then 1 times x is x. Plus we have the x minus 6 times the 4. Nothing cancels there. And on the other side of the equal sign, we have x minus 6 times 6 over x minus 6. And the x minus 6 over x minus 6 cancels, because anything divided by itself would just be 1. And then 1 times 6 is 6. Okay, so look what we have now. X plus 4 times x minus 6 equals 6. Remove the parentheses. X plus 4x minus 24 equals 6. Combine like terms. 5x from the x plus 4x minus 24 equals 6. We want the x term by itself, so get rid of the minus 24 by adding plus 24 to both sides. 5x equals 30. Now divide both sides by 5, and we get x equals 6. So yay, we're done. That's the solution, right? Well, let's go back and check it in the original equation, make sure it works. If we replace every x in that equation by 6, look what we get. 6 over 0 plus 4 equals 6 over 0. Wait a minute. 6 over 0? You can't have 0 in the denominator. 6 over 0 or 6 divided by 0. That's undefined. You're not allowed to do that. So, looks like we have a problem with x being 6. That's not really a solution. That doesn't really satisfy the original equation. So what went wrong? Well, in this step here, when we multiplied both sides by x minus 6, remember I said we can multiply both sides of an equation by any number except 0. We're not allowed to multiply both sides by 0 because that just kills everything off. Well, if x happened to be 6, then x minus 6 would have been 0, and we would have been multiplying both sides by 0. So that's why that got us into trouble. So the moral of the story is, if you're going to multiply both sides by an expression with a variable in it, like we did here, then whatever you get for your solution, you got to be a little bit suspicious of. You got to go back and check in the original equation, would that make any of the denominators 0? And if it does give you a 0 in the denominator, then you have to throw that out. It's not really a solution. We call it an extraneous solution. So in this case, this equation has no solution. It's a contradiction. So if an equation involves fractions, multiply both sides of the equation by the denominator or by a common denominator of all the fractions if there are more than one, and this will allow you to cancel all the denominators. Once you get a solution, check it to make sure it doesn't give you a 0 in any denominator in the original equation. If it does, that makes it an extraneous solution, one that's not really a solution to the original equation. And in that case, that original equation might not have any solutions. Okay, one more example. Okay, here I see lots of fractions, and we need to find a common denominator of all of them. And that would be easier to do if we knew what factors this was made up of. So I'm going to start by taking this denominator here, x squared plus 3x minus 10, and factoring it. It factors into x plus 5 times x minus 2. So a common denominator would be made up of x plus 5 times x minus 2. That would be divisible by x plus 5. It would be divisible by x minus 2, and it would be divisible by both of those together. So that's what I'm going to multiply on both sides. I'm multiplying both sides of this equation by x plus 5 times x minus 2. And remember, that means that each term gets multiplied by that. We got x plus 5 times x minus 2 times this first fraction, 2 over x plus 5, minus, we got x plus 5 times x minus 2 times 1 over x minus 2. And then over on the other side of the equal sign, we got x plus 5 times x minus 2 times 3 over x plus 5 times x minus 2. Okay, that looks like a mess, but it's the kind of mess that it's going to clean itself up a lot because some things are going to cancel. X plus 5 over x plus 5 cancels. X minus 2 over x minus 2 cancels. And x plus 5 times x minus 2 cancels over here. So, ta-da! No more fractions. Here's what's left. 2 times x minus 2 minus 1 times x plus 5 equals 3. Okay, that doesn't look too bad. We can solve that. Distribute out the parentheses. 2x minus 4 minus 1x, or just minus x, minus 5 equals 3. Combine like terms. From 2x minus x, we get x. From minus 4 minus 5, we get minus 9. So x minus 9 equals 3. Add 9 to both sides, so x equals 12. And now check. If x is 12, does that make any of these denominators 0? And no, I don't think it does. 12 plus 5 wouldn't be 0. 12 minus 2 wouldn't be 0. And those two things multiplied together would not be 0. So yeah, we're good. 12 is the solution to this equation.